15 or 14 questions, 15 questions for homework last night. Page 63, number 2 to 16. Which of these 15 questions would you like to take a look at? Let's pick a couple of them to do before we do the quiz. 14? 14 and 6 works for me. You know what? That works out perfectly, actually, because if we add 14 to 6, we get 20, and then it's like a game of 20 questions, right? Instead of actual work. It's like a game now. So 14 and 6 work out perfectly. Let's do 6 first. 6 says, at the beginning of a game, a referee throws a basketball vertically upward with an initial speed of 5.0 meters per second. Determine the maximum height above the floor reached by the basketball if it starts from a height of 1.5 meters. That's a good question. I remember yesterday, I think it was, somebody asking me about that question. It's a good one. Here's what I want to do for this one, okay? It's not always necessary, but sometimes it's very useful. Draw a little picture. We have to write down givens, okay? If it's useful to draw a picture, then we might as well do that because it's not all that much more work. We got to write down our givens anyways. Let's just draw a picture here and put the givens right on the picture. So here we're starting from 1.50 meters above the ground. The ball starts right here with an initial speed of 5.0 meters per second. It's going to go up here, and then it's going to come back down to the ground level. Now, what I want to do in this question, we want to, by the way, get the maximum height above the floor. So we want to get this distance right there. What I want to do is not actually get that distance right away. What I want to do is get this distance right away. Let's get the maximum height of the ball above where it started. Okay, does that make sense? So I'm going to say delta D is equal to, no, you know what? I was going to say delta D is equal to VIT plus 1/2 AT squared. Is that a valid equation? Could I try that one? VIT plus 1/2 AT squared? I could, but is it going to be helpful to me? No, it's not, because I don't know what delta T is. All right. So I made a little mistake, no big deal. Okay, in the end, it's not going to give me a wrong answer because it's a valid equation. Let's try this one. VF squared is equal to VI squared plus 2AD. Is this one going to work for me? I've got VI is 5. I've got A, it's neg 9.81. Delta D is what I'm looking for. VF is, oh, we don't know what that is either, do we? Or do we? It's 0. If we're analyzing the trip up to its maximum height, then VF would be 0 meters per second. That allows us to find delta D. So let's rearrange here. Let's say VF squared minus VI squared. Let's take the VI squared over by subtracting because it's not attached to the delta D. Now let's take the 2A over by dividing because it is attached. So it becomes VF squared minus VI squared over 2A equals delta D. VF is 0 minus 5 over 2 times neg 9.81. So we get there, neg 25 divided by neg 19.62. It's somewhere around 1.25. What is it? Is 1.25. Okay. So that gives me 1.25 meters. Not a final answer, though, is it? That's my displacement from here to the top. Now, if I want the displacement from the ground, then I've got to add that to the 1.5 meters. Right, Kate? Is that good? Does that make sense, guys? How many people got that one? Good. Okay, the other one that we wanted to go over was number, which one was it? 14? Says a person in an apartment building is 5 meters above a person walking below. She plans to drop some keys to him. He is currently walking directly toward the point below her at 2.75 meters per second. How far away is he if he catches the keys 1.25 meters above the ground? Wow. Yeah, I don't know about you guys, but when I read that question for the first time, I think, Well, I don't even know where to start on this. Or I almost think that. Okay, in the end, what you got to recognize here is that there's really two things happening here, right? There's the falling of the keys, and then there's the person walking forward. And those two events are completely independent of each other. They don't have any bearing on each other whatsoever. Does that make sense? Right? The person the person dropping the keys, or the person, I should say, that is walking and catching the keys, has no bearing on the motion of the keys. The motion of the keys has no bearing on the motion of the person walking. So what we're going to do is treat them separately, at least for now. Okay, let's write down some givens for the dropping keys. Let's write down some givens for the person walking. And let's treat them separately, and then if we have to put them together later on, we'll worry about that later on. The person in the apartment building is 5 meters above the person walking below. She plans to drop some keys. He is walking at 2.75 meters. So we're going to say this is 2.75 meters per second. That's a constant velocity. We know that dropping keys experience an acceleration, not a constant velocity, of negative 9.81 meters per second squared. How far away is he if he catches the keys 1.25 meters above the ground? So we're going to say the displacement of the keys is going to be what? How far are the keys falling? Yeah, 3.75 meters. We're going to make that negative, though, because it's downwards, right? Why negative 3.75? He's 5 meters up, but the guy catches them 1.25 meters up, so the displacement of the keys ends up being negative 3.75. Make sense? All right, well, we want to find delta D right here, how far away this guy is, the person walking from the keys. Doesn't look like we have a whole lot here. Okay, we know that this is a group B problem because the keys are accelerating. This is a group A problem because the person's walking at a constant velocity. Group A is an easier equation. D is equal to delta D over delta T. So let's start with that one first. Delta D over delta T, and see if we can make this work. Rearrange it, take the T up by multiplying, it becomes V times T. I got V, I don't know what T is though. All right, so I can't do that right now. I know I'm going to have to at some point because the person walking is experiencing constant velocity, and this is the only equation I have for it. So I know I'm going to need to get T, and I know I'm going to need to plug it into here. Well, let's go back to the dropping keys. Let's see how long the keys drop for. Let's say D for this one, for the dropping keys, D is equal to VIT plus 1/2 AT squared. If the keys are dropped, then VI would be equal to 0. Let's solve for T here. Let's take the half A over by dividing, delta D over 1/2 A. And now let's square root that. So delta T becomes the square root of delta D over 1/2 of A. So we're going to say it's delta D, which is negative 3.75, over 1/2 of negative 9.81, and then we're going to square root that. Does anybody have a value for that T? Has anybody calculated that? All right, let's pull up the calculator then and see what we get. Let's say negative 3.75, divided by, use some brackets here, 0.5 times negative 9.81. Now we're going to square root that. When we square root that, we get a time of 0.8744. 0.8744 seconds. That's how long the keys fall for. Well, if the keys fall for 0.8744 seconds, how long is the guy walking? 0.8744 seconds. So now let's multiply the velocity here, 2.75 meters per second, by that time of 0.8744. We multiply those two numbers together, we get 2.4 meters. Does that make sense? Your quiz question today is not going to be that hard. Okay, I can promise you that. That's a good question, though. I love that question. How many people got that answer? Good. Excellent. Okay, listen, if you're getting an answer like that, You're going to have no problem with today's quiz. You're going to have no problem with your unit test, which will be in just over a week. Okay, not next week, but the following week. Okay, you're not going to have any trouble with any of that stuff. Okay, not in terms of this material, anyways, because it's not going to get harder than that question. That's a good question, especially those of you who got it without my help. Okay, that's fantastic because you have to think about that, right? You have to really understand things. It's good.